Okay, I'm going to do a little Excel primer on how I want you to use Excel to analyze the data that we collected together and will collect together over the course of the semester. Okay, so for the purposes of this example, I'm going to use some fake data. The experiment is going to be an experiment where we have a cart rolling down a hill, and we're going to make measurements of the speed of that cart as a function of time, and then we're going to analyze those data. Okay, so my variable for my independent variable is going to be time. I'm going to be making measurements of the speed of a cart for various times. So I'm going to label my first column time. I'm going to put in units of seconds. Okay, and my time will be, I'll make measurements at 1 second intervals, up to 10 seconds. So I'm going to generate the time values for 0 to 10 seconds. Okay. And then I'm going to generate values for the speed, right? The speed, these are values I would measure, right? I'd collect my data and I put my numbers in here, but I'm going to generate some fake data here. So I'm going to make 3 trials. I'm going to measure speed for every time 3 times so I can average them and get some idea of the uncertainty. Okay, so the title for this column is going to be speed. This is the measured speed, right? And it's going to be trial 1, trial number 1. And the units on this are in meters per second. Okay, that's my first trial. Then I'm going to do my second trial. My second trial is going to be also speed, trial number 2, and this is also in meters per second. And finally, my third trial and final trial. Column heading here is speed, trial number 3, and the units again are meters per second. So what you would normally do, right, is once you have these column headings, you would enter the collected data into these columns, right? Now, since we didn't really do this experiment, I'm going to generate some fake data with noise so that we can use them to do the analysis. Okay, so just my model, my fake data, I'm going to generate. So let me do that. And that's my fake data. And I'm going to add some noise to it. Some random noise. Okay, and I'm going to generate that noisy data for all times for my first trial. Okay, so there's my noisy data for my first trial. And then I'm going to do the same thing for my second trial and my third trial. So here's my noisy data for my second trial. And I'm going to do the same thing for my third trial. Okay, so you've taken all your data, you've collected your data, you've put your data in your spreadsheet. Now we want to analyze these data. So the first thing I'm going to do is I'm going to average these 3 trials to get a single value for speed to plot. So speed, I'm going to label this speed average, and the units of this, of course, are again meters per second. And I'm going to use the average function in Excel to average all of the data that I have for that time. So basically these 3 cells for this time. Okay, that's the average of those 3. And I'm going to take the average for all times, for every time point. And so there are my average speeds. Okay, this is what I'm going to plot. The other thing I need to generate some uncertainties, right? A measure of the error or experimental random uncertainty. So I'm going to create a column. I'm going to call that delta speed in units of meters per second. Like that. I'm going to make this a delta, so let me just change this to a Greek letter. And for the uncertainty, I'm going to use the standard deviation. Use the standard deviation function, stdev, of the 3 data points that I have. And that'll give me an estimate of the error or the uncertainty in my measurements. Okay, and I'm going to extend that for all times. So now I have my times, I have my measured value for the speed at that time, and I have an error or uncertainty on every data point. Okay, so now I want to plot these. So I'm going to choose, this is my x-axis, along my x-axis, my x variable. I'm going to hold down Control and choose, this is my y-axis, and I'm going to insert a chart. So I'm going to go to Insert. I'm going to insert a scatter plot without any lines. We don't want any lines. Okay, so there's my scatter plot. Okay, the first thing I want to do with this is I want to add a trend line. So I'm going to click on Chart Elements, and I'm going to go to Trend Line. I'm going to pick Trend Line. Okay, and I'm going to go to, and so there's my trend line. It fit a straight line. You can see the straight line goes through most of the points, and it's close to the other points. I also want to include the equation for this trend line on my graph. So I'm going to go to More Options. And under More Options, I'm going to scroll down to where it says Display Equation on Chart. Okay, so there I have my equation, and I'm going to move that out of the way for a little bit right now, and then we'll clean that up in a bit. Okay, so let me move this equation out of the way a little bit. And we'll work on that in a while. Okay, all right. The next thing I want to do is I want to extend my x-axis to negative values. I just want to show you how to do that. So I'm going to again click on this Chart Elements button, and I'm going to choose Axes, and I'm going to choose More Options for the axes. So More Options. And here you see where it has a bounds. I'm going to change the bounds, the lower bound to -12. Okay, so there you go. I now have extended my x-axis to negative values of time because I want you to know how to do that. Okay. The next thing I want to do is, since I now have extended my x values to -12 seconds, I want to extend my trend line also. So I'm going to go back here. I'm going to go to the trend line. I'm going to choose More Options. And under More Options, you see here that there is this, what they call the forecast. You can, what they call forecast backwards. And I'm going to put in how far back I want to go. So I want to go back by 12 units. So 12 there, and extend my trend line back to -12. So now I have my data plotted. I have a trend line that I fit. I have that trend line extended to negative values. The next thing I want to do is I want to put in my uncertainties, my error bars on these data. I'm going to get those uncertainties from this column F. Okay, to do that, I'll click on Chart Elements, and I will choose error bars. So it puts in the standard error bars, which we don't want. So I'm going to have to modify that. So I'm going to go to More Options. For the, I don't want X error values. There's no there's no uncertainty in the X values. So I'm going to remove those by deleting them. But I'm going to choose, let's see, let me go back to error bars. Error bars, More Options. Okay, and I'm going to replace these standard error bars that they have here, that Excel has here, with custom error bars. Okay, so I'm going to specify the value of those guys. And the idea is that for my positive X, I'm going to choose these values in my F column. So I'm going to choose the values in my F column there. And then for the negative value and for the positive negative values, I'm also going to choose the same values in my F column. I'm going to plot those. And there you have it. So there you have, now you can see the error bars on the plot. Okay, so the next thing I want to do is, I don't like this title. I'm going to change the title to something that's more, that tells me more about what this graph is. So I'm going to change this title. No, I don't want to do that. I'm going to change this title to something that tells me what this graph represents. So I'm going to say speed of a cart rolling downhill. That tells me exactly what this chart represents. Okay. And in addition to that, what I also need is I also need to put in labels on my axes, so it's clear what my axes represent. So I'm going to go axis titles, choose axis titles. Okay. And now I'm going to edit those titles. Let me move this over. So let me center this. Center this nicely. Okay. I'm going to center this nicely. And now I'm going to edit these axis titles. So this is V, and the units are seconds. And this here is T, and the units are, sorry, seconds. Here the units are meters per second. Meters per second. All right, so now I almost have everything I want. The only thing I want to do is I want to edit this equation for the fit. So I want to make it a little bit bigger so I can see it. So I'm going to change this font size. So I'm going to change it to like 11. That sounds good. And I want to change these variables because I'm not dealing with y and x, I'm dealing with v and t. So this is v of t is equal to this times t as opposed to x. Okay. And the other thing I want to do is I want to put in units for these fit parameters. So let me move this over here. Okay, let me put in units. So the units for this fit parameter here are meters per second squared. And for the intercept, the units are meters per second. Please. Meters per second squared. And the units, I don't need the star here. I can get rid of that. And here for the units for the y-intercept, the y-intercept is just speed, so meters per second. Okay. So there we have our graph. Okay, I can move this. That's a good place to have it, I suppose. Maybe I'll move it a little bit. Let me put it down here. Okay, so there's our graph. Okay, let me move this a little bit on my spreadsheet. I'll put that there. Okay, now the next thing I want to do before I turn this in is I want to put in a text box. I'm going to put in a text box where I'll put my abstract and I'll answer questions about the experiment. Okay, from the handout that I have. Okay, so I'm going to go to Insert. I'm going to insert a text box. So here's my text box. I'm going to put it here. You can put more than one text box in more than one place, but I'm just going to, for this example, I'm just going to make one text box. And in that text box, I'm going to include an abstract. Okay, so that's basically a short description of my experiment. So I'm going to say, in this experiment, we measured we determined the acceleration of a cart rolling downhill. I'll put in a sentence about how we did that. We measured the speed of the block as a function of time and fit a straight line to the data. The slope of the fit gave us an acceleration of a equal to 0.5377 meters per second. Here's my abstract, okay? A description of the experiment, why we did the experiment, how we made the measurement, and what our result was. Okay, there's my abstract. There's a short abstract. Then I'm going to put in answers to questions from the handout. So I'll have answers to questions, and I'll have, A, labeling them the way they were in the handout, answer to question A, B, answer to question B. You don't have to put these all in one box. You can put in multiple boxes. But anyway, this is sort of a general idea of how I want you to present your informal lab reports. So there's my abstract, very important, and then the answers to the questions that you're required to answer in the handout. Give that a title there, underline it. Okay, and I put in the information here. Okay, maybe I'll bold that also. Okay. All right. And of course, you want to be saving this. And when you save it, you'll print it to a PDF, and then you'll submit the PDF to Blackboard to be graded. Okay. So that's it.